Hey guys, welcome back to another Leetcode video. Today we're going to be looking at Leetcode 54201 matrix. We're given an n by n binary matrix and we need to return the distance of the nearest zero for each cell. The distance between two cells sharing a common edge is we're told as 1. So in this example, we're given 0, 0, 0, 1, 0, 0, and the distance matrix that we return is going to be exactly the same. The result is exactly the same because all these zeros are, the nearest zero is themselves, so they just return 0, and 1 is 1 away from any of the 4 zeros that is adjacent to. So we return 1 for that as well. In this example, we return 1 for 0 for these 5 zeros, 1 for these, because we've got 1 and 0, which is only one distance away. However, for this cell, we can see that it would take, either 2 up or right and then up, or left and then up. But the distance from the nearest 0 is 2, so we would set the distance to 2, and that's the output we would give. So we basically need to return a distance matrix, and we're told it's either each side either only going to be 0 or 1, and there's at least 1 0 in our matrix. Okay, so how can we solve this problem? Well, this looks like a multi-source BFS problem. We need to do kind of like ripples, and we need to get the distance for each cell, and we need to do this iteratively with a breadth first search approach and use a queue data structure for this. So let's hop straight into the code. We'll be using Go today. We want to first get the number of rows and columns. So we're going to set equal to length of mat, and cols is going to be the length of mat 0. Okay, so what do we need to do now? We need to create our distance matrix. So let's say our distance matrix is going to be equal to, we're going to use make function, and we want our matrix to be a 2-dimensional array with R amount of rows. And we want to say, now let's create our column. So let's say for I in range of our distance matrix. So right now we just have empty rows which are set to 0. So let's create those columns. So dist I equals make just a integer array, and the number of those is going to be the number of columns we have. So we've basically now created our the exact same number of rows and columns in our matrix. We have basically an empty copy of the binary matrix we're given. So now what we need to do is let's fill all the ones. Actually, let's fill the entire matrix with negative ones, just to mark that they have not been visited yet. Okay, so you can say let's say for j in range, using Python syntax over there, in range distance I, let's set distance I j equal to -1. Okay, fantastic. So we've now created a distance matrix with all the values being -1. What do we need to do now? So now it's time to fill in all the zeros as zeros and initialize our queue. So we know that in Python in Python we have like a queue data structure, or in other languages we might have a queue data structure. In Go we don't, so we need to create our own. We need to use lists as queues, but before that we need to create a tuple data structure so we can store the pairs of coordinates efficiently. So let's create that tuple data structure. R, C, so a row and column, and they're both going to be integers. And then we want to set our queue data structure equal to this list of pairs. And boom, we've got our tuple data structure. So now let's go through each zero in our matrix, and let's set those in our distance matrix, and also append them to our queue, so that we can be ready for our BFS. So we're going to say for R or 0, R is less than rows, R plus plus. Fantastic. And I'll just copy and paste this for C as well. C is less than cols, C plus plus. Fantastic. So what can we do now? Well, we can say if matrix RC equals 0, we'll set in our distance matrix, dist RC is also going to be equal to 0. We also want to append to our queue the coordinates. So we're prepared for doing our BFS. So it's just going to be a pair of R and C. Okay, fantastic. Now it's time for the most important part of this problem, of the solution, and it's actually doing multiple source BFS. Okay, so as with any BFS problem, we want to get our decisions. So it's going to be pairs, and our pairs are going to be, sorry, not our decisions, our directions. Our directions are going to be pairs, and we're going to go first top, bottom, we want to go left, we want to go right, and then we want to go left. Doesn't matter which order, we can do any order. And then we're going to do a while loop. Again, while loops. So we're going to say for, as long as our queue is not empty, so as long as our queue is greater than 0, current is going to be equal to q0, and we're also going to want to have to pop. So we'll just set q. We can just set q equal to, and just slice off everything beyond our first index. So that's how we're going to pop. And again, I'm going for Python syntax. Sorry guys, I mainly code in Python, as you know, so this is kind of new to me. Okay, so what we want to say now is for direction and directions, I'm doing it again, range directions, nr nc is going to be equal to current.r and current.c plus d.r and d.c. So these are going to be our new coordinates now. And now we want to check, are they in bounds? So if nr is greater than or equal to 0, and nc is greater than or equal to 0, and nr is less than rows, and nc is less than rows, and we also want to check nr nc equals -1. If this is the case, we know that we're in bounds, so we can update our distance matrix. So we'll set distance nc, or distance nr nc equal to distance current.r and distance current.c plus 1. So we want to get our current at the distance of our current coordinates, and we want to add 1 to our new coordinates. So this is going to be the new distance. And again, what we want to do now is append. So we want to append to our queue the pairs. So q, and we're going to append nr and nc. So we're going to append our new coordinates to our queue. So we're going to have that ripple effect, that BFS effect. We're going to go through the grid with like a wave effect. And once we've finished our while loop, we will have a completed distance matrix. So we can just return distance. So hopefully that works. And we get an issue declared and not used queue. Okay, we can just say q equals append directions undefined pairs. Oh, we need to set this type to pairs. But actually, we can set that to pair and then set this to pair instead of pairs. And we have been submitting too frequently. So let's just look at, do we have any other bugs? I don't think so. And we have another bug as well. We don't want to do that because that makes no sense. We want to go from 1 to the end of the list. And in the last case, we have declared and not used queue. So we keep declaring when we've already declared queue. Okay, now we pass our sample test cases. Let's submit and make sure we have no other syntax issues. And we get an index out of range with length 1. Yeah, let's hop through the code for this. If nr is greater than or equal to 0 and nc is greater than or equal to 0, it's less than rows, and nc is less than cols is what this should be. Okay, fantastic. We finally got there after a bunch of issues. But I hope you guys enjoyed this video. And oh yeah, in terms of time and space complexity, we're looking at an O of m times by n time and space. So I hope you guys enjoyed this video again, and I'll catch you in the next one.